Hello guys, I'm going to show you how to derive the quadratic equation. So, when you're deriving the quadratic equation, it works by completing the square. If you're not sure how to complete the square, I have another video on it, just previous to this one. But let's get on with it then. Let's see what we can do when we complete the square. So, when we complete the square, we take out the coefficient of x squared out of the equation. So if we do that, we put this in square brackets, we shall get x squared by itself. But also we have to take out a out of bx and c too, or it won't work properly. So add b over a x plus c over a, and that equals 0. As always, you haven't done anything yet with it, so you can keep 0 the same. So now we'll complete the square. So a, because now we've taken the coefficient out, we can go about completing the square. And as you know, what we do is we just take x squared to become x in this little bracket, and then we add half of b over ax. So, and we don't have to put the x in as well. You can keep that out because that'll come soon. And this is squared, by the way, too. So then we have to minus b over a to the power of 2. So if we just go over here now, so what does b over a divided by 2. So if it's divided by 2, I'll just put 2a there. But if it's squared, if all that is squared, remember I have to square both the top and the bottom. It'll be b squared over 4a squared. And that'll be it. So always remember you have to minus it. It doesn't matter if you're squaring it or not. If you have to minus it, whatever you get. So it's b squared over 4a squared. Because when you square it, it makes a positive anyway, so you have to minus it as it's part of the completing the square. And then plus c over a as usual. And this all equals 0. And then what we do next is we multiply a by the square brackets and bring it back into the equation. So if we do that, so a x plus b over a squared, and that's remember you're gonna have to in fact, before we do that, just rub this out actually. Gone a step too far actually. What you have to do first before you do that is I need to get this bit outside the bracket into like a single fraction. Otherwise, it'll just make it more complicated. So when we do something as a fraction, we have to get all the denominators the same. So b over a. This is squared. That's an awful a. Shall do that again. This is a, right. To let you know what we're doing, so what we're going to do, we're going to multiply. I want to get c over a to 4a squared. So what I do multiply it by 4a. I multiply it by 4a because a times a is a squared, and then times by 4 makes it 4a squared. But remember, I have to do the top as well as the bottom. So if I do that, minus, I'll just show it on this side, so you know what I'm talking about. So b squared over 4a squared plus, so it'll be 4a and then c over 4a squared. As you can see, I was able to get them the same because I multiplied the c over a by 4a, which made the denominator the same. And you can combine them, so you can put it under the same denominator, which is 4a squared. Sorry, I'm not very good at writing. Minus, yeah, because it's you're minusing this, because it's a minus b squared over 4a squared plus 4ac. And then I'll put that in brackets so we know where this is comes from. And then that equals 0. I'm brilliant, so... And then we'll do what I was supposed to do before, which is put it back together. So if I do this, a x plus b over a squared. So multiply it together. So yeah, I'm just thinking, am I doing this right? Yeah, I think so. Yeah, it should be fine. Yeah, minus. Now, with this one here, because I can multiply it by a, I don't have to put it on b squared or 4ac. I can just cancel it out with the denominator. So I can do b squared plus 4ac, as usual, divided by 4a. Because we got rid of one of the a's by cancelling it out. That makes the denominator small. Usually if you're multiplying something with something, it makes the opposite, the flip of the coin, shall we say, smaller, but the flip of the coin on the top, so what it's trying to multiply with, it makes it, increases it, shall we say, or decreases it, depending what number it is, if it's a minus number or a fraction. But yeah, it's a bit complicated, sorry about that. Yeah, and that equals 0. Now, when I get this one, remember we can put it as 0 still, because we haven't done anything to the other side. What we can do now, we can add this to the other side, so if I write out that again, a plus b over a squared equals b squared plus 4ac over 4a. Yep, and the next thing we need to do is get rid of the a on the left side. So if I do this, x plus b over a, this remains the same until we square root it, so we don't do anything with it. And then obviously this equals b squared plus 4ac. Now we're doing the reverse of what we did just in this here. We're basically just multiplying it by its inverse. So you're going to multiply the denominator higher, shall we say, 4a squared. So yeah, it's 4a squared, because we divided it. Now, the next section is, I'm gonna rub the bit on the left. And yeah, we've got here. And then now what we're going to do is square root it. So x plus b over a squared equals I've made an error. Sorry about this, guys. B over a, it's supposed to say b over 2a. Sorry about that. Because remember when I divided it, you increased the denominator by another one. So sorry, I made an error there. In fact, I'll change all these to 2 ways. It all happened in the brackets, so hopefully you're looking at it now and thinking, oh, that makes sense now. But yeah, sorry about that. I should be a bit more organised when I'm doing this. Since we're square rooting it, we don't need this, and then if I get my brush back, 4ac over, remember 4a squared, and we're square rooting this. So I put a big square root over it. Now the interesting thing is, now you can't square root the bottom bit, right? You can't square root. You can't square root the top bit. It's a plus something. When something's a plus something, I'm not sure how they do it, but there is no known way of doing it as such. There probably is somewhere, but I think it's more complicated. So generally we ignore that bit. You can't square root that. You have to just leave that as a square root. But you can square root the bottom bit though, because that's that's by itself in the fraction. So we can do that. So we'll do that first before we move on to the next step. X plus b over 2a, remember, not a, sorry, equals. Now, we'll leave the top bit, so this is b squared. I also remember, it's plus or minus as well. When it comes to quadratic equation, it's plus or minus because it could be a minus, it could be a negative. Or it could be a positive. Sorry. Yeah. So b squared plus 4ac. Now divide it all by the square root of 4a squared. What's the square root of 4a squared? Well, if you square root 4, that's 2. That's 2. And if you square root a, it's just a. Because a times a is a squared. And then the final step is, or the nearly final step, is we'll put this to this side here. We'll get that to that side. So it's x equals minus b over 2a plus or minus square root of b squared plus 4ac over, oh wait, I nearly made an error there. Remember, I've already done the bottom bit, so I don't have to square root that bit again. So over 2a. And then, as we can see there, we can, because the bottom two, so these two are the same, so we can combine it. What? So we'll combine it. So x equals minus b plus or minus square root of b squared plus 4a. Wait, have I eliminated 4ac? It's c, 4ac. Sorry about that. And then that's over 2a. I keep the minus to the b, that just keeps it within. You could, arguably, I think you could you? Though? No, actually no, because 2a and 2a, they have to keep the same. 2a can't be minus. So yeah, just minus b, keep that as the minus. And there we have it. That's the quadratic equation, how you derive it. Sorry. Yeah, that's it. Yeah, I hope it was useful. It makes sense where it comes from. I don't like not knowing where something comes from because it makes you doubt, doesn't it? Whereas if you know where it comes from, you can derive it from base principle. Then, great. Maybe in the next video I'll show you how to use this to work out certain roots of equations. Because usually when it's got decimals in, like an equation, it can be a bit annoying. And some roots, there are roots there, but it's like 2.148 or something, or some kind of weird rubbish, that the mind without calculator can do. So yeah. I hope this was useful, and I'll catch you in the next video. Take care.